Hello, everyone. Let's look at a few homework examples from section 9.3. That's about saving money. I find that this is the area when we start having all of these different types of formulas. When do we use the formula? How do we enter it in the calculator? The most challenging part of this module is typically how to enter it in the calculator. So let's start with this first example. Ryan starts an IRA at the age of 32 to save for retirement. He deposits $400 each month. Upon retirement at the age of 65, his retirement savings is $642,327.56. Determine the amount of money Ryan deposits over the length of the investment and how much he made in interest upon retirement. So first off, this one has no big formula that I actually have to use. We're going to just use some basic common sense. So starting at age 32 and he's going to retire at 65. So his years between that, the years he's investing is going to be the difference of those two, which gives you 33 years. Okay, in those 33 years, let's think about what they're doing. He's depositing $400 each month. Okay, so let's figure out how much he is actually putting in the account or total deposit into that. So starting off, we have the A value, that's your input here, is $400 per month. Well, if we times that by 12 months in 1 year, because that's a conversion, I actually have $4,800 per year that he's depositing. But the grand total is going to take the total deposit is going to be your 4,800. Sorry if you can't read that. In a year times 33 years. Then your years cancel. You get the grand total of 158,400. So that would be his deposited amount. So that goes there in your answers. Then it asks us to determine how much interest did he actually gain. Well, credit cards, we're paying interest, but this one, we want the money from it. So the retirement savings has this grand total, a nice chunk of money there. And so what we're taking is just common sense. We're going to take 642,327.56, which represents the ending balance. That's both pieces, what's deposited and the interest. Subtract what he deposited, and that's his deposited money that he did. He ends up with $483,927.56. That is how much money he made off the interest. He must have got some nice return. I wish I had known more about this in my younger years and not tried to play catch up now in my older years. So if you're at all possible, even if you just put $100 away a month, if you can ever put away some and just keep doing it and never touch it, what a huge amount of interest you can gain off of that by the time you retire. Okay, moving down to, sorry about that, I'm just going to move that up. Number 2, let's look at this one. We have Amelia wishes to retire at 67 years old with $1.9 million in her retirement account. When she turns 25, she decides to begin depositing money into an account with an APR of 8%. What is the monthly deposit that Amelia must make in order to reach her goal? Round your answer to the nearest cent, if necessary. Well, let's figure out what information we have. We have this beautiful amount she wants in her ending balance. So that's that future value, that FV that we have in some of our formulas. That would be 1.9 million. And then let's see, how many years is that between her age? So her time is always in years, would be 67 minus 25, because here's what we have. We're going to be going 42 years. Now, the other items we need to know is what the rate, they told us that one. We have a rate. So our rate, which is our R, is going to equal 8%, but we must change that to a decimal, so we divide by 100 or move it 2 decimal places to the left, and you get 0.08. Now, that in value, how many times in a month is it used? That in value, instead of just saying the number, it is stated right here, monthly deposit. That is your in. It's going to be 12. Now, when it comes to exams, you're going to be given formulas, so you don't need to memorize every single formula, especially these big, hairy ones. You always have that on your exam as a reference. So don't stress about that to begin with. Just a FYI so you know. Looking at here, I made a quick list of formulas from that unit or section. Let me just put that up here. So off those ones, we're wanting to find out the payment amount. We're actually going to use this last one because we want to know how much to be depositing per month to make her dreams come true. Well, the nice thing is it's just like a puzzle, just fill it in. So my payment, PMT, is going to equal my future value, which is 1.9 million. So I'll write it out though. And there's a little dot here. It's kind of hard to see on my paper. That means multiplication. I'm going to use a bracket for that. We have the numerator and the denominator. So in the numerator, I got the rate, so 0.08 divided by n, which is 12. In the denominator, it gets a little bit crazier. I have 1, just the plain old 1, plus, again, 0.08 over 12 to the nt. Nt is 12 times 42, and then we subtract 1, all in bracket, and that's inside. Now, this is where you might get the setup and then not the answer correct, but the setup is correct. It's all based on how you enter it in the calculator. Now, the book already indicated how to add extra parentheses and such. Well, if you get confused on that, I wanted to show you another way of doing so. We can just work inside out. Now, no, I do have a TI-84, ignore it. A regular calculator, just any scientific, is going to work just fine. So what I like to do, inside out, I'll get the numerator separate from the denominator as another method. So what is 0.08 divided by 12? I get 0.006 repetent, basically. So I'm going to just put that here. Now this is, again, just another option for you. You do not have to do it this way. You can add the parentheses. This is times 0.0666666. It rounds to 7 because it has to end on the screen. It's really 6 repetent. And then I have in the denominator inside out. Figure out what 12 times 42 is, or have it already in an extra parenthesis. I can do it both ways, but I have 504. So I know that this amount is 504. Now, working inside out, I will go ahead and do this item. So 0.08 divided by 12, enter. Add my 1 plus 1. This is my inside number. I'm not going to copy or do any of that. I'm just going to take it to the exponent of 504. So then we take it to the exponent of 504. I don't have to re-enter it. I hit enter, and then I'm going to subtract 1. And I get what the denominator would be. 27.46996097. And it just depends on your calculator type. You can copy and save that, reuse that, but maybe your calculator doesn't have that, or you don't know how to use that. So then we're just going to put this in to the best of your ability, 2 zeros and the rest 6s. I go several out because it makes it more accurate. Divide by the number that you got, 6097 equals this item. Don't stress, just times it by the 1.9 million. 1, 2, 3, and there we are. This is just this little e to the negative 4. If you ever get something like that, that just means that I move the decimal in the negative direction 4 places. So it would actually be 0.00024 such and such. But this calculator does scientific notation, many of them will. So our final answer is rounded to the nearest cent is going to be $461.11 per month. So if you can put $461.11, if you get a good percentage rate at 8%, which doesn't exist right now, but she's going to have 1.9 million in 42 years. Even if you just had $1 million, that'd be huge. Again, I wish I had known more about this in my younger years. So if you get that opportunity to start putting some aside, as little as you can possibly, even if it's little, but as much as you possibly can do, never know what you would have when you finish. I hope that helps. You have a wonderful day.